Hi, this video is called Solving Linear Systems by Elimination, Part 2. In Part 1, we solved the system that is shown in green here, x minus 3y equals negative 5 and negative x plus 6y equals 11. And the nice thing about that problem was that the coefficients of um, x in each of those two were opposite numbers. You had 1 next to that x and negative 1 in front of this x. When you add 1 and negative 1, if we add the equations vertically, the x term will go to 0. So you'll just have the two y terms and the two numbers. Okay, so that made it easier because they gave it to us in a form which already was ready for elimination. In this next example, which is in black, the coefficients are not set up to allow you to just simply add the two equations and make one of the variables disappear. Because if we add these, you can see very quickly that neither the x terms nor the y terms will go to 0. So we're going to have to change one of these equations so that when we add the terms, one of the variables will go to 0, will turn into a 0. And let's see what I mean by that. Imagine that if this 3x here was actually a 6x, then when we added this 6x to that negative 6x above it, we would get a 0. So if I can just convert this to a 6x, well, in order to do that, we're going to have to multiply the 3x times 2. And since we cannot just multiply 3x by 2, we have to multiply everything in this equation by 2. So I'm going to put parentheses and say we have to multiply everything by 2. Okay? So I'm going to rewrite, in a minute I'm going to multiply everything by 2, but first I'm going to rewrite the first equation and say negative 6x plus 9y equals negative 6. And then I'm going to multiply 2 by every term in the second equation and get 6x minus 2y equals 20. Okay? If you see what I did there, this equation now appears down here, but it is multiplied by 2. Now watch what happens. If I want to add these two, if I go ahead and add these two equations vertically, you get negative 6x plus 6x is 0. You get 9y plus negative 2y, which is 9 minus 2 is 7, so that'll be 7y. And then you'll get 20 plus negative 6 is 14. So 7y equals 14. That's looking like a problem that we could solve very easily. If we divide both sides by 7, we're going to get y on one side, and we're going to get 14 divided by 7, or 2 on the other side. So it looks like we've solved for y. Okay, now we need to solve for x, because remember, the solution to a system of linear equations is an ordered pair. And this is the y value of the ordered pair. How do we solve for the x? How do we calculate x? We pick one of the first two equations, either the negative 6x or the 3x equation, and substitute. We rewrite it, but we substitute 2 instead of y. Let's try that with the second equation. So it says 3x minus y equals 10. But we're going to write it as 3x minus 2, because now we have a value for y. And write it as 3x minus 2 equals 10. Then we're going to add 2 to both sides. And when we say both sides, remember that means both sides of the equal sign. So this is going to be 3x on the left, and on the right it's going to be 12. 3x equals 12. Again, it looks like this is going to be an easy solution. If we divide 3x by 3, we get x. 12 divided by 3 is 4, and we have x equals 4. So what's our ordered pair? It's xy, which is 4, 2. Okay? Now, in order to make sure that we have the right solution, we have to go back and plug these values into the original equations. So I'm going to have to go to a new page, which I'm going to do now, and I'm going to have to rewrite these two equations really quickly. So I have negative 6x plus 9y equals negative 6. And what was the other one? 6x minus 2y, 3x minus y equals 10. 3x minus y equals 10. Now we're going to take our ordered pair 4, 2 and check and substitute x equals 4 and y equals 2 into each of these. So let's start with negative 6 times 4 plus 9 times 2 equals negative 6. We don't know if that's true. We could write a question mark above this, but let's just leave it like this and see what we get. Negative 6 times 4, negative 24. 9 times 2, positive 18. And so if you have negative 24, so it's a larger negative number and a smaller positive number, this is going to be negative 6. So you can see that this does equal negative 6. And so we know that our ordered pair 4, 2 does satisfy the first equation. Now we're going to go try the second equation. Okay, 3x minus y equals 10. So again, we'll write 3x, but instead of x, we'll write 4. And then instead of y, we'll write 2. And we're going to see if that equals 10. 3 times 4, 12, minus 2. 12 minus 2 does equal 10. So now we know that the ordered pair 4, 2 makes both these equations true, or it satisfies both equations. And so our ordered pair 4, 2 is correct.